Hopefully this quick video might be useful to anyone planning to add motion to their projects. They might be building a robot or something with flaps that need to open and close. I'll just put this little video together about some servos. I've got a new servo here off the interweb. Quite a nice little servo. I'll introduce it in a moment. But first of all, this is your kind of traditional servo that you might come across. Now this one is called the 9G Micro Servo. The traditional kind of servos typically move backwards and forwards to about 180 degrees. This arm here, which is attached, you'll see it rotates, but it reaches a limit around about here, and then it comes back this way and it reaches a limit there. Now they might actually look like it goes just over 180, but it could possibly move a bit further than 180. It might only take a signal and move between there and there. We'll test that in a bit. The next servo is a continuous rotation servo. So it looks basically the same. I think this is a continuous one. I'm not sure. I've got a couple and I bought some, and two of them were meant to be continuous servos, but when I got them they're actually 180 servos. Contacted the seller and I thought it was quite strange because it had a number on it for a continuous, and they said well that was okay, and they sent me two more and they were continuous. Now the continuous, of course, as it's named, should go, how good can I draw a circle, 360, but then once it gets there it keeps going. So that one just spins around like a traditional motor, but what's the point of that? Well, by controlling it the same as you control this servo, you can actually adjust the speed and kind of tick it one degree at a time, or whatever resolution your particular servo has. So that will just continue to rotate. You shouldn't really do this while I'm rotating them by hand, because you can damage the gears inside, but I find if you go very, very gently and don't try and force it, it will just turn. But people tell you shouldn't really do that. These ones I think have got metal gears, so they're fine. These cheaper 9Gs, they have little nylon gears inside. You can see the gears in there. If you're not careful, you'll break some of those gears in there or grind them down. Now the new little servo I've got, which is absolutely tiny, I didn't imagine it was this tiny, is this little servo. And this is a linear servo. So this has a little arm on it, hopefully you can just about see it. It's tiny. That actually moves backwards and forwards. I'm not actually sure of the distance this thing measures. I did just look it up online. There is no dimensions given for its overall size or how far backwards and forwards it goes. The only thing it does say is 360 degrees, which obviously this is not a 360 degree servo. So I actually bought it for visual aesthetics rather than knowing what it actually did. You know, it looks like it will move backwards and forwards about 12. Let's get a bit closer, you can't see that. Yeah, about 13, I'm going to say 12 millimeters, this particular one. Now I'll actually want this because I want it to pull some little push rods backwards and forwards. You might want that in a model aircraft. I want it for a little robot project I'm going to do. I think it's obviously much smaller than this servo, so you can cram more of them in there. But I'm not actually sure of the strength. Now the strength can be given in torque usually on these. I might try and see if I can get an equivalent torque reading off this. You'll notice the connector on the end is absolutely tiny compared to this, so to plug it into the Arduino I can't put pins in there. I'm going to have to cut it off because I don't have any pins small enough. I could probably put wires in there, but I'm going to put some pins in. I did just go ahead and explain how you drive one of these servo motors, but I do seem to be having some trouble with micro SD cards at the moment. The one in the camera here keeps corrupting or buffering out and stopping, and I had the one in my phone that was 64 gigs just stopped working. Kept trying to format it. All the data that was on there kept reappearing and I couldn't add any new data, which I've read is apparently something to do with it reaching its maximum read and write cycles. So micro SD card ran over. Hopefully I can continue about it cutting out again. So essentially you've got three wires on these servos. Most of them are the same. You've got red for positive and you feed them with 5 volts DC from somewhere. If you've got a few of them, you're going to overload an Arduino or something like that, so you'll have to have a separate power supply for those. You have a black or a brown, that's for the ground, and then you usually have a yellow or a white for the signal cable. So as we look at these, brown, red, yellow, and this much smaller one here is red, black, white. Both is fine. Now what we do is we feed a digital signal in on the S or the yellow or whatever it is, and it's normally a PWM, which stands for pulse width modulation. Now here we have some examples of a digital square wave, and in this digital square wave you can see that it's off, then on, off, then on, and it's about equal timing, as close as I could do. So this is what we'd call a 50% mark space. The mark space is referring to the ratio that it's off to on or on to off. We could have 0% where it's just a flat line along 0 volts, and we could have 0 volts. We could have this one where it's plus volts, which would be on all the time, 100%. So we'll divide that up. Now if we're going to go and look at, say, an Arduino to drive this, we would use the servo library that has some built-in code for driving servos, and we would feed some numbers between 0 and 225 to the servo motor, and that would actually vary it. Now not all the servos have 225 available positions, but they will close to approximately the right number. What you'll actually do is map this number out here to the actual numbers that the servo can support. If that's something you want to do, simply load up the Arduino software, look down the examples, and down the examples you'll find servo, and a good servo program to start with is the one called Knob, which you can actually download. I believe you connect the servo to pin 9, so the signal, and you feed in a variable resistor to analog 0. Now load it up, have a look, it's pretty self-explanatory. Connect your components up, the 3 wires. Bear in mind if you're driving a big servo you're probably going to need an extra power supply, so feed in some beefy 5 volts from somewhere. That's it really. You turn the knob on the control and it will work. So here's one I made earlier. I've got my little Arduino here. This is obviously what I'm using, but you could use a Raspberry Pi or a Pickaxe or a PIC itself or an ARM-based processor. You could even use an Intel one if you've got some money to flash about. What I've got here is variable resistor plugged in. If you need a bit more advice on that, you've got 3 pins. One on the top positive, one at the bottom negative or ground. The one in the middle is going to come off to analog pin 0. And what we do is by turning this we basically take the voltage between 5 and 0. Now I've plugged in my little servo into this board, pin 9 as it was. I'm a little bit miffed because yeah, it does move, it moves quite nicely, and I get about my centimetre, and it's not really, I guess, the device's fault, but it will go a bit further beyond its limits and kind of get jammed up there. Once it gets jammed, it's actually stuck. Doesn't want to come back. There you go, it's come back there. But it does stick up there. Now what can I do about that? Well, I guess what you need to do is do some experiments where you read the number back from the servo, back to the PC, I mean, from the Arduino. And what we would do then is actually set kind of maximum limit for this. You might find that as we increase this up there, the value at a, I don't know, 200 or 245 takes it just near the end, and then we say that's the maximum that we're going to allow it to move, just so it doesn't get bound up. That might be good practice in a lot of projects. You don't want the thing moving too far and jamming against something, causing damage or getting stuck or damaging the servo itself. So yeah, it does get stuck at both ends. It's stuck at that end. I give it a little twist, a little kind of tickle on the end there, and that kind of unjams it. But it's not happy about getting jammed, and it's obviously getting quite warm, which is now melting the blue tack. Have I got my ruler there? Do a little test on that. Let's get it close up there. So about a centimetre. is its safe limit. You kind of want to avoid that last millimetre. As you can see, it gets bound up and doesn't come back. Linear servo. Here we have our traditional servo, the 180, and again we turn this control and we can see it moves backwards and forwards. This one does suffer with a little bit of instability. You can see it wobbling there. That instability is either, yeah, there we go, look, the wire's broken off. Very thin wires here. Any kind of instability in your motor is going to be either down to bad wiring, like it is here. It could be actually that your potentiometer's old, and if it's old it might be a bit corroded. See, now that I hold that on there firmly, that responds quite a bit better. You can see I can move it quite slowly, move it a little bit at a time, and what I'll do now is solder this wire back on and test the next one. Finally is our continuous rotation servo. This one's a little bit different. If the signal is exactly 50-50 mark space, or half on half off, the servo will stay still. If we decrease it, it will go backwards. You do have finer control, but this particular variable resistor doesn't seem to do it justice. Okay, but as I crank it up it gets faster. And then if we go the other way, we get a finer rotation. I do think my variable resistor is not as great as it could be. You'll notice when I let go of it, it changes. When I touch it, it changes. But you get the idea. We can actually make this go around pretty slowly. Or we can actually have it go around at not a great speed, but a little bit quicker. There you have it. 3 different servos for 3 different purposes. This one is ideal for maybe a wheel on a robot that can make it go very slowly or speed up and help with the steering. Or possibly you might use it for something like a conveyor belt. Anything where you need continuous rotation. This one on the other hand is perfect for moving kind of push rods backwards and forwards, or maybe having little bucket flaps that open, or opening a little trap door, or just pulling on a lever to make something else move elsewhere. This one on the other hand, I haven't got around to using it yet, but I plan to do pretty much the same with this one, push a lever backwards and forwards, but it obviously uses much less space. I could probably cram, what, 1, 2, 3, 4 of those into the same space as this little one here. So that will actually allow me to hopefully do something quite complex. We'll look at that in later videos. One last thing I think which is worth mentioning here is if you plan to use a brushless motor, these are those kind of motors you might be using for a quadcopter or an RC car. They're usually quite fast in RPM and quite powerful. They require a special driver, one of these ESCs or electronic speed controllers. They're sold as ESCs. They'll be measured in amps suitable for the motor. What they do is they convert your DC current or your DC voltage coming in here to a kind of stepped voltage that's suitable for driving these motors. If you put DC on these, you'll burn them out. It actually switches 2 coils on and then changes to the other 2 and switches which ones it's switched on. They also come with this 3-pin connector. On this one it's red, black and white. They work off the same servo signals that you get from the Arduino servo out, or I guess from any kind of little project board. So send a servo signal to these. Now these generally need some setup procedures. For example, they'll only activate the motor if they're switched on with 0 mark space, or in the middle maybe. Perhaps they need throttle all the way down, or perhaps they need throttle up. That would usually be sent by kind of a RC controller from an RC signal pack, you know what I mean, like for flying your aeroplane with a little box. But you can actually drive them straight off the Arduino port as well, or the servo driver. Really, it's best for you to have a little play around, see which ones you get on with. These are quite expensive, about £4. These are less than £1 you can pick those up for. These ones probably about £4 again, something like that. Have a look around. Thanks for watching. If you'd like to see more, like and subscribe. Any requests, just jot it down below.